In our previous video sequence, we talked about what sequences were, and now we're moving on to talking about something called series. So the idea here is that a sequence is simply an ordered list of numbers. So we talked in the previous video that a sequence might be something like 1, 3, 5, 7, 9, right? Now in an informal sense, a series is just the ordered sum of the terms of a sequence. So the series associated with that sequence would be 1 plus 3 plus 5 plus 7 plus 9 plus, and so on. So the thing I want you to remember is that every series is associated with a sequence of terms. Like, you can't have a series if you don't have a sequence. A series just means you're taking a sequence and adding up all of the terms instead of just thinking about them as disjoint numbers in a list of numbers. There's a notation that we use to go along with sequences. And the notation is written below, right? This thing will sum the terms of the sequence AI from 0 up to n. So this notation right here means take a sub, we'll start with 0, plus a sub 1, plus a sub 2, and keep doing that until you get to whatever number's up here, a sub n. Right? So that's what that notation means, right? So as a very simple example, if I asked you to do the sum n equals 2 to 5 of n, it would mean use the sequence n. So not even like AI this time, just the sequence n. So we would take 2 plus 3 plus 4 plus 5, and if we sum those up, we'll end up with 14. So here's another example for us. It's sort of similar to that simple one we did previously, but it's a little bit more complicated. So pause the video, try this one out for yourself. What we should do is we need to evaluate this expression using the numbers between 3 and 6, right? So it means I'm going to have 3 squared minus 4 plus 4 squared minus 4 plus 5 squared minus 4 and then plus 6 squared minus 4. So we can simplify this. This will be 5 plus 12 plus 21 plus 32. So combining the stuff together, these give me 17, these give me 53, and so when we add both of these together, we end up with 70. Okay? So the purpose of this slide was really just to give you a sense for this notation and how that notation works and what we do with it. So there's one last concept for me to get to you in this video, and that's the concept of a partial sum. And this is a fairly important conceptual thing, right? So the nth partial sum of a sequence is the sum of the first n terms of that sequence. And the notation that's generally used for it is Sn. And so what that means is it means that you're going to start with whatever term you're at, like, a sub 0, a sub 1, a sub 2, and add together until you get to a sub n. The nth partial sum of a sequence means add up the first n terms of that sequence, right? So I'm going to ask here, compute the first 3 partial sums of the sequence for n greater than or equal to 0. Right? So that means I'm going to need to compute S0 and S1 and S2. These would be the first 3 partial sums of the sequence. Now, in order to do that, I'm probably going to need to write down what the first several terms are. I'll need to start with what is a sub 0. Well, a sub 0 would be, if I evaluate this for 0, I'll have 1 over 2 to the first, which is 1 over 2. If I do a sub 1, it'll be 1 over 2 squared, so that's 1/4. If I do a sub 2, it'll be 1 over 2 cubed, which is 1/8. Great. Now that I have the first few terms of the sequence, I can write down what the partial sums are. S0 is the sum of the 0th term, so that's 1/2. S1 will be a0 plus a1. So it'll be 1/2 plus 1/4, which is 3/4. S sub 2 will be the sum of the terms up to n equals 2. Means it'll be a0 plus a1 plus a2, and that for me is going to be 7/8. These are the first three partial sums of the sequence. Understanding what partial sums are goes a long way to helping us understand what's really happening with series as we dig deeper into this chapter. So make sure you take a little bit of time just to make sure that you've processed what a partial sum is. We'll talk soon about what we use it for.